So highlighting the pgBouncer functionality in 4.3. What's interesting is there probably was not that much that was added to pgBouncer. It was mostly we tightened up the integration of pgBouncer because pgBouncer is ultimately very powerful. It's more than just a connection pooler. It's a connection state manager, and we're just scratching the surface of how we can fully leverage the pgBouncer functionality in the Postgres operator. The first thing really was just to clean up the integration. And what came of it is that you can now manage pgBouncer fully from the custom resource. This is more and more Kubernetes operator workloads are moving towards this custom resource only methodology, and so too we are trying to move the operator more towards that. We've included pgBouncer management. We've included pgBouncer management, but we've included resource management as well. So you can adjust the resources pgBouncer uses. We support password rotation for it, which I'll touch a little bit on as we go through it. We have the ability to run pgBouncer replicas. So you can run more than one pgBouncer instance, giving it a little bit more resiliency. So I will now again do the annoying switching of presentation views. And I shall, first I gotta find my demo. So I'm gonna create a pgBouncer instance. It's gonna have two replicas. It's gonna have 0.15, I guess 150 millicores of CPU and 38 megabytes of RAM. And if I do a describe on it, sorry, deployment. Can see that that is exactly what I asked for. That's that's what I got. And to show that it created everything, it created all the pods. We have two pgBouncer pods. Now, in the previous versions of the operator, you did not have two pgBouncer pods. You only had one. So this is particularly exciting. So the other thing is how we manage the pgBouncer user account. pgBouncer has a user account called pgBouncer, which is really there for administrative tasks around pgBouncer. It's actually how the pgBouncer FTW works. It uses that account to get the statistics. Unless I've said something that's untrue, I believe that's how it works. But it's really there for administrative purposes. Now we used to showcase the pgBouncer user as just a regular old Postgres user, but it's not. It really has two roles. One, it's that administrative account. It's also used to facilitate authentications, in a secure manner between pgBouncer and Postgres itself. So let's. I'm gonna create a port forward to pgBouncer so we can log in. We're first gonna log in as a regular old user. And apparently I do not have. That's right. I deleted my hippo user. There you go, I'm logged in. This is my Postgres server. I believe our IDs table is still there. Yep, so see, nothing up my sleeve. Everything's works, everything's integrated. It's a good time. So let's look at what happens if we try logging in as the pgBouncer user. So this is gonna log into that, as I mentioned, that administrative area of pgBouncer. As you can see, the connection string changed. I'm logged in pgBouncer. I could do the things like show stats, and I could see some stats like, oh look, that's cool. Like the hippo login has only run one transaction, and that's all it's done. So yeah, that's pretty cool. We can facilitate that from the operator. Importantly, we can also do updates. So in this case, we realized, oh, there's a lot of usage of pgBouncer. We need to up the resources, or actually in this case, set some resource limits on it. And if we go to describe, describe the deployment, we can see that all that information is propagated to it. So, other things we can do. So the one thing is we treat the pgBouncer account as a system account, which means, we want to, limit, how much access is, given to it. So, for instance, resetting the password, we have this thing called rotate password that's set up for it. So, because, it's good to rotate the passwords from time to time. In which cases you can see this password. If you'd memorized the password previously, this is, totally different. Another change we made is that we upped our password random generation entropy. So we're using pretty much the full typable ASCII character set. maybe minus 1 or 2 characters, or it might be the full set, but we want to maximize the entropy because why not? It's more secure. So we can also, reduce the number of replicas or increase the number of replicas in pgBouncer as well. So if you go back to that earlier query, as you can see, we have less pods now. So, scaling works.